Imagine you have an electronic component with 3 leads, but no clear labels. How do you figure out which lead does what, especially for a crucial switching device like a Silicon Controlled Rectifier, or SCR? Identifying the anode, cathode, and gate terminals of an SCR involves a combination of examining its physical package, understanding its internal semiconductor structure, and often performing specific electrical tests. The reason we can distinguish these terminals lies in the SCR's unique 4-layer PNP semiconductor construction. This structure dictates that the anode is the terminal where current enters and is connected to the outermost P layer, while the cathode is where current exits and is connected to the outermost N layer. The gate, which triggers the SCR into conduction, is connected to an inner P layer, requiring only a small current injection to initiate a much larger anode to cathode current flow. This distinct internal arrangement means each terminal interacts differently with external circuitry. To practically identify these terminals, begin by looking for any markings on the SCR's package, as manufacturers often provide a data sheet or a diagram for common types. If no markings are present, you can use a multimeter. Measure the resistance between each pair of terminals. The gate-to-cathode junction will typically behave like a diode, showing a low resistance in one direction and high resistance in the reverse. The anode-to-cathode path will usually show very high resistance in both directions until the device is triggered. A common package is the TO220, where often the middle pin is the anode, but always verify. Understanding the internal construction of the SCR is a real insider detail. For instance, the gate acts like a control valve, but only for current from the anode to the cathode, not the other way around. This unidirectional control is critical. Also, knowing that the SCR latches on, meaning it stays conducting even after the gate signal is removed, is key to confirming proper terminal identification through testing. Accurately identifying the anode, cathode, and gate of an SCR is essential for proper circuit design and operation. It ensures the device functions correctly as a controlled switch, preventing damage and enabling reliable power control in various applications, from motor speed control to lighting dimmers. Knowing these terminals allows you to effectively integrate SCRs into your electronic projects.